Hello everyone, this is Dr. Marrero from Math Topics. Welcome to this series, How Do I Teach Math? How Do I Learn Math? If you have visited our channel, you can see the playlist in our channel. If this is your first time, I invite you to go to Math Topics channels and check the wonderful work that we have there. Usually I have different approaches in teaching mathematics and to make possible the students learn. And one of those approaches is the following that I'm going to share with you right now. It's about some words that are very similar. Well, they're the same words that physics use it, but it's not a physics class. It's in terms of pedagogy. How can I approach a particular topic in mathematics using some ideas or some words that they have important meanings, not only for the teacher who is teaching, but also for the student that is learning. Let's see it now. Suppose that you are going to teach linear function. You are going to teach algebra, linear function. And you are in the pre-planning process. And this is not only for teachers. This is also for parents that want to help their kids learning mathematics. I use a particular approach that I'm going to share with you right now. I'm going to start from zero. And the way that I see it is what I'm going to explain right now. So I'm assuming that the students don't know anything. So linear function, I know the content, I know the objective of that content, I know the long range objective of that important content in algebra, algebra 1 or middle school 8th grade, also they start with linear function. The problem is, and the challenge is, how to deliver the content, how to deliver the elements of that content, the procedural mathematics involved in that content, how to deliver the conceptual mathematics of that problem. I use the following ideas. I use the word space. I use the word objects. Objects can be elements. I use the word conservation. That is associated with constant. And I use the word predictable, okay, that we are going to predict. We are going to forecast. And I'm going to leave it right there. Space, objects, conservation, predictable. What is a space? This is not a physics class. This is a pedagogical approach to mathematics teaching and learning. What is the space? Okay, the space is that blank sheet of paper that you see there. Is where you as a teacher, you as a parent, and the students will be working on. It's what I call, let me use a different color, the framework of my teaching approach, and it will be the framework for students. What is that space? It's not a three-dimensional space. It's not a 3D. It's not physics. It's let's say, the area in which the objects will be moving, the elements of the topic will be moving. And in this case, because we are working with linear function, okay? Linear function. My space here is the coordinate system. The Cartesian coordinate system, okay? The beautiful X and Y approach. You have no idea how many students in 8th grade math, even in high school math, they know the existence of the X and Y coordinate, and they know some aspects, but they forget many other aspects of the coordinate system. And this is critical. This is the first target, the space. The students need to know, hey, you are going to be playing right here, and these are the rules of the field. These are the rules of the game. Like if you're playing a baseball game. So what the first things that is discussed, the rules of the field. That happens right before the games start. The same for football or any other sport. So the student needs to know the space. What will be the space that we're going to be working in mathematics, in linear function? Okay, the X and Y coordinate is the playground, is the framework. Then the objects. Okay, what are the objects? The elements. Okay, we're gonna be working with points. Okay, and those points have a structure, X and Y. It's important that the students know that structure is an object moving. That object will be moving in function transformations. For example, that object, this is the single and the simplest element of that space, the point. And sometimes it's difficult for students to understand the magnitude of that simplest object that is a point. When they see a function, and I'm talking about linear function, no? And they see the function, and they see that that function contain points, no? Contains those elements. And by the way, those elements that respond to the particular rule, that is the function, they make another object, and the other object here is a line. Geometrically speaking, a line. Algebraically speaking, y equal mx plus b, or y minus y1 equal m times x minus x1, or ax plus by equals c. Different forms to write the same geometrical structure. But look, space, points, lines, algebra integration. Of course, we have more objects. We have more objects, but we have numbers. Because both axes contains all the numbers, from negative infinity to positive infinity. And those numbers are constant. So they have a special characteristics, the conservation of its magnitude. If you say number one won't change. Number two won't change. 1/2 won't change. And that idea of conservation of the magnitude of the number, which is the value, is what I call here conservation. What else is conservation? Okay, the slope of that line. Okay, the rise over run that we use to find the slope from that perspective is also something constant in linear functions. So, and it's a constant because the slope is a number. Okay, the slope is a number. So if you introduce numbers as a constant with that property of conservation, okay, then the students can understand that the slope is also a number. Of course, it's going to have the same property. The slope is constant. It will conserve its value along the line. I'm speaking in general ways. The topic from the pre-planning perspective. So the slope is a number. You have no idea how many students, when you show them the line y equals 3x minus 1, and you ask them, what is the slope? They said 3x. When they said that, it's because they have a gap in understanding that the slope is a number. Of course, that is delta y over delta x, but that produces a number, it's a fraction. And the number has a very fundamental property. They conserve the value by itself, the identity. 2 is equal to the reflection of the number. So space, framework, objects, the elements, conservation, the constant, predictable. What is predictable? This is fundamental in learning and teaching math. How to predict the outcome. If we know the characteristics of the object, of the element, and we know those characteristics and the actions in which that object is involved, we can predict the outcome. Mm-hmm. So if we have y equals 3x and we have the object 2 and 2, that's the point, that's an object, 2, 2. And I know that x is equal 2 and y is equal 2, we can predict the outcome of that point if we use it in the function. Okay? So let's say that the x is equal 5. If I can predict the outcome. So if I put here y equals, 3 times 5 minus 1, I can predict the output. 3 times 5, 15. 15 minus 1 is 14. So I can predict the output. Predictable. We can forecast before the action. And all of that happening within the space, within the framework, within the coordinate system in this particular case. What else? I like change. Change is another important word that I use to deliver. What will be changing? And of course, change is related with variables. And this is something that is linked to the objects in the framework. Think about it. Too many things can be done with this approach. The space, for example, is the framework not only for linear function, it's a framework for mathematics, it's a framework for algebra and geometry integration. But when you deliver the instruction based on these ideas, space, objects, conservation, forecasts, changing, you can explore the rest of the topic and the content using the same format, the same, let's say, structure. And for example, if you come on, this is what I'm trying to explain. If you come with another function that is not a linear function, I'm going to use, I don't know, right here, y equals x squared, the quadratic function, the parabola. And the students see it, okay? And if they learn the framework here, the objects, and this is what I call a set of learning, a set of learning linear functions, and you come up with y equal x to the power of 2, the student said it's another object, but it's not an object that belongs to that set. How do you know it? Because they know that that object can be represented in the same space. Yes, but it's not part of the set because they know the elements, they know the objects, they know the points, they know the slope, they know the variables, they know that a linear function is a polynomial with degree 1. Okay? Y equals mx plus b, ax plus by equals c. And there is something here that is not similar to my objects. And this is the way everyone learns lifetime. So if you talk to me about linear function, I cannot accept y equals x to the second power. And why I cannot accept it? Because in my mind, y equals x to the second power contain many of the objects of the linear function, the point, the space, but it's not the same structure as a linear function. It's a quadratic structure. And then you can say, okay, we can use this new object, which is a quadratic function. We're going to use it in the same space. We're going to use the same points, the same elements, x and y, but we cannot predict it in the same way because, by the way, the slope of a curve is not constant. It will be something that will change. The forecast will be similar but not the same. The behavior of the geometrical object, that is the parabola, is not the same as a line. And then teaching and learning becomes in learning and teaching sets. What is the set of linear functions? If you can secure that information, the students only need to change some elements in the rest of the study of functions. And when I said y equals x to the second power, I can say the exponential functions. No? I can say, I don't know, y equals a to the x, or y equals e to the x, or y equals the natural log of x, or y equals sine of x, or y equals cosine of x. So let's say that every single one of those functions respond to a set of elements working in a particular space with particular properties that can make the prediction different, that you can forecast the answer in a different way because they are different objects. Of course, they are functions, but function is a general idea. Function is a general concept, definition. But inside that set of function, we have different other sets of function. And the students start finding similarities and contrasts between the different set of learning. Set of learning. Create a set of learning using a space, objects, conservation, forecast, variables, changing, and of course, the last and the top, the application. But we cannot apply without knowing the set of learning. This is the video today. I don't want to extend it more. We can talk about this a lot. But think about this idea to deliver effective mathematics instruction and effective mathematics learning, lifetime learning. How to create our set of learning using framework, space, objects that will be moving, conservation, who is going to stay constant, who is going to change. So the student is going to say, oh, the x and the y will be changing, and then the word variable makes sense for them. Because if you said a point is x and y, that's it. They need to know how the properties of that point. That point will be moving in a dual motion, to the right, up, to the left, down, to the right, left. The dual motion of those objects, how they move. So it's important to create a set of learning using a space, object, conservation, predictable, changing, and of course at the end, the application. And then you establish what I said, the connection between the set of learning. When you establish the connection between the set of learning, boom, the students has a strong foundation in mathematics, a strong foundation in mathematics. Don't believe that Albert Einstein learned first mathematics and then physics. It's impossible. But the way he learned mathematics was super strong and lifetime learning. Because learn mathematics as a set of learning, creating set of learning, knowing exactly the properties and the characteristics of the objects and the space they are moving. Thank you for watching the video. Thank you for supporting Math Topics. See you in the next video. Thank you.